We're now ready to begin our measurement process. And the measurement process will consist of 3 steps. The first one is to isolate the ranging component of the tracker. The second step we have is to calibrate the bar. And we're going to actually value the bar so that it is our qualified reference for the third step of our process, which is to measure the bar. We'll measure it in 5 orientations according to the NIST IR 8016 procedure, and that will give us the data that we need to do the analysis with KinAiry. So we're ready to begin our measurement process, and we're going to go to step 1, which is isolating the ranging component on the tracker. So to do that, I'm going to set a measurement mode here in our software. I'm going to be in the ADM measurement mode for our process because I will be breaking the beam. So to do that, I'm going to take the SMR and I'm going to track it over here to our alignment mirror. And I'm going to break the beam so I get a reflection off of the mirror. I'm going to come around here and I'm going to pick that beam back up off the reflection, and then we'll take that and we'll set it in this target A. Now I know that I have the tracker reflecting off the mirror and pointing through this first point, point A. I'm going to rotate that SMR to break the beam and keep the beam oriented right on the target. So our goal is to buck in or align this tracker to this beam. Now if I come down here, I'm going to take the SMR and I'll set it in my C target. I don't know if the camera can pick it up or not, but there is a red dot over to the side of the SMR. I need that dot to be in the center of this sphere. So to accomplish that, all I have to do is come back over to my mirror. I've got some threaded adjustments that I can use to actually track that reflected beam back to the center of the ball. And I'm looking over the top of it to get it good side to side. I just look for the brightest return I can get, and then I do the same thing vertically to set that on. That looks pretty good. Now I can take the SMR, I can rotate that down and pick up the optics to begin my measurement process. So I need to check that buck in on the bar to begin with, so I'm going to go back to my utility in this live data screen. This time I'm going to work with the azimuth and the elevation encoders. The requirement out of the NIST IR 8016 procedure is that the angular error be no greater than 0.1 degrees for either one of these encoders. So we're going to make a mental note to say we're at 0.02 for the azimuth and call it 0.39, if you will, for the elevation. So we're 02 and 39. So let's track the ball back to A. 02 and 39 were the numbers we were looking for. We're at 04 and 39, so we're well within the 0.1 tolerance that we were looking for the angularity. We also need to have a measurement profile defined as we go through this process. And the measurement profile we like to use is to take half a second of data and let the tracker run at its sampling rate. For this tracker, it's 3,000 samples per second, I think. So we're going to get about 1,500 samples for the calculation of this one point. That's sufficient for our purposes. So now we know that we've got the tracker bucked into the bar, and that is step 1. That's the isolation of the ranging component. So we've accomplished that. Now we need to move to step 2, which is to calibrate the bar itself.